Right. So obviously we are recording this discussion and we're getting ourselves started, and you need to make sure that you understand what is happening here. But first, let's look at what momentum is. So we look at a definition. So looking at a definition. Right, this definition focuses on what momentum. So we say the momentum. Right, we call the momentum P of an object. Is the product of the mass m and velocity. Because they can ask you in the exam, in metric, they can ask you in the exam, what is momentum of the object? Okay. We're covering the definitions so that you're able to know what is happening. Okay. The question we're asking is, what is momentum? So obviously now we know that momentum of the momentum of an object is the product of the mass and the velocity of the object. And in symbols, because normally we use formulas. And what is the formula for momentum that we use? Right. Because according to this, it says that if you need to calculate the momentum of an object, we note that the momentum is the mass of the object multiplied by the velocity of the object, like so. Right. So that momentum itself is the mass multiplied by the velocity. Okay, so this is something that you need to note. We ask you a couple of questions about this momentum. Is it a vector? Is it a scalar? Okay, momentum is a vector quantity. Momentum, right, because now everything we study in physics, we ask ourselves if it is a vector or a scalar, if it has direction or not. So momentum is a vector quantity. Right, this vector quantity is a vector quantity so that it has magnitude and direction. Magnitude and direction. Okay, obviously we note that the magnitude is the what? The magnitude is the size and direction. Right, there's something called the standard international unit. The SI, standard international unit. What is the unit? Because we measure distance in meters, and the meter is the SI unit of distance. But what is the SI unit of momentum? The SI unit of momentum, okay, because now somebody says, what is the momentum of the car? And then you say the momentum of the car is 20, but we need to state the unit, and we say the SI unit of momentum is the kilogram, meters per second, kilogram, meters per second. Okay, this is the SI unit of momentum. Okay, momentum is singular, and if there are many, we say they are momenta. They are momenta in plural form. Okay, right. However, we need to proceed to look at some examples here, because in the exam, they're not just going to ask you to only do this, but they're going to ask you to actually sort of calculate. Use the formulas. If you have the SI unit, you have the formula, and you have the actual definition. So we continue. Now, let's look at an example here. Example 1. Right. In example 1, we speak about a cyclist. With a mass. With a mass of 83 kilograms. Rides on his bicycle with a mass of 37 kilograms at a velocity of 8 meters per second in a direction in an eastern direction. Right, in an eastern direction. Right, in an eastern direction. Okay, now we continue. First, question 1. We need to calculate the momentum. Of the cyclist. Two. Wait. I'm just use some parentheses here. It doesn't matter for the numbering. So yeah, we need to calculate the momentum of the cyclist. You must be able to draw and name the cyclist's velocity and momentum. Vectors. Number 3, calculate the momentum of both the cyclist and that of his bicycle. Right, of his bicycle. Okay, we'll continue quickly. Four, if the cyclist, right, if the cyclists, okay, velocity doubles. If the cyclist velocity doubles, so in other words, is moving faster, doubles. Okay, with with which factor will his momentum increase? And here we say confirm your answer with a calculation. With a calculation. Okay, let's look at the solution to this. What is the solution to this example? Right, the first question. Right, what we write first is called data. So a cyclist with a mass of 83 kilograms rides on his bicycle with a mass. So first things first, because now we must write the given information. So in other words, we're dealing with a cyclist with a mass of this, rides on his bicycle with a mass of this at a velocity of 8 meters per second in an eastern direction. Calculate the momentum of the cyclist. Okay, so we need the momentum of the cyclist. So we write down the data. What is the mass of this cyclist? A cyclist with a mass of 83 kilograms. So the mass is actually 83 kilograms. The velocity. The velocity, okay, he rides on his bicycle with a mass of this. The bicycle has a mass of 37 kilograms at a velocity of 8 meters per second in an eastern direction. So yeah, the velocity is 8 meters per second. It's exactly 8 meters per second. Okay, right. And the momentum is what the question wants. What is the momentum? P. Because you're saying calculate the momentum of the cyclist. So yeah, we have the data. We have the given information about the mass of the cyclist and the velocity of the cyclist. And because the cyclist is on the bike, they have the same velocity. If like you are in a car, you have the same velocity as the car relative to the ground. Okay, because if the car is moving at 120 kilometers per hour, it means you are also moving at 120 kilometers per hour in the direction of the velocity of the car. Velocity being a vector quantity. So the formula for momentum, we need the momentum. So momentum is mass times velocity, which means we put the mass. What is the mass? The mass is actually 83 kilograms. And we multiply this with the velocity of the cyclist. The cyclist is the person who is riding on the bike. And therefore, we have this 83 by 8. And 83 times 8 is 664 kilograms meters per second. Okay, momentum is a vector. When you state your momentum, always give the direction. What is the direction of the cyclist? What is the direction of the cyclist? Okay, so we see that the direction of the cyclist is east.
East.
It is east, okay, because we were told that at a velocity of 8 meters per second in an eastern direction. So it is in an eastern direction, and therefore we note that it is most certainly east there. That becomes the direction of the cyclist. Okay, so that is just something for you to note there. Okay, we continue. Okay, but what is number 2? Draw and name the cyclist velocity and momentum vectors. Right. Draw and name the cyclist velocity and momentum vectors. Okay, let's draw number 2. Right, number 2, we need to draw. So we're just going to draw the vectors. How do we draw the vectors? So we explore that part. We explore that part on how we draw the vectors. Just a sec. Right. Right, the way we draw the vectors is as follows. So we're going to say, for example, here is one vector. And this vector is 8 meters per second. East. Right? So now the momentum vector, this is the velocity vector. The momentum vector has P equals 664 kilograms meters per second. East. Right. So in other words, we have that this is east and that is east. But why are they different? Why is one longer and the other one shorter? Because we understand that the momentum vector is 664. 664 is larger. So it's a larger magnitude than 8. Okay, because the vector consists of the size, the magnitude. So 664 is bigger than 8. Okay, so we have drawn the vectors, but they must have the size and the direction. So we have east, both of them. Both the velocity is 8, and it has its own direction east, and the momentum is in the direction of the velocity east as well. Okay, let's look at number 3. Calculate the momentum of both the cyclist and that of his bike, of his bicycle. Calculate the momentum of both the cyclist and that of, because in one we did only the momentum of the cyclist, of the guy who is riding, of the rider. Now we are saying both the cyclist, the guy riding, and the bicycle, what is their combined momentum? So we look at number 3, combined momentum. So 3. Right, so to find the combined momentum, we need to focus on data, calculation. What is the data? Right, the data obviously focuses on the momentum P. What is it? Okay, that's the question. What is the momentum? But we need the mass, the combined mass. Okay, we know that the rider has a mass of 83 kilograms. The bicycle has a mass of 37 kilograms, and the summation, okay, the summation 80 plus 30 is 110. So this is like 120. Yes, it is 120 kilograms, because there is a rider on the bike, and now we want to know the mass of everything. If you add the mass of both the rider and the bicycle, okay, what is the velocity? Okay, we know very well that the rider and this bicycle are moving at 8 meters per second relative to the ground. Okay, this is relativity. We always say your velocity is this relative to something. So, meaning the momentum is mass times velocity. What is the mass? Okay, we have seen that the mass is 120 kilograms. The velocity is 8 meters per second. And if we consider all these, 8 by 120 is 960 kilograms. So this is exactly 960 kilograms meters per second. Okay, momentum being a vector, what is the direction? The direction is surely in the easterly direction. And we have just done that, and that is certainly the solution there. Okay, right. We have found the momentum of the bicycle and also of the cyclist on the bike. Now let's look at the fourth question. If the cyclist velocity doubles, with which factor will his momentum increase? Okay, confirm your answer with a calculation. So we're saying the velocity is doubling. What is the velocity here? The velocity is 8. So if you double 8, what does it become? Okay, so That is what you need to think about. Let's look at number 4. Right. Look at number 4. We are effectively saying first things first, the guy is on the bike, but suddenly, boom, the velocity is now double. So first, we look at the data. We are seeing now the velocity is double. So double means it is 2 times 8, which is 16 meters per second. Right. So the mass of the cyclist, 83 kilograms. The momentum is, what is it? We want to find it. We want to find the momentum. So we have this. Okay, there are a couple of ways to obviously do this question. So which means that the momentum formula is P equals mv, and therefore the mass is 83 kilograms. The velocity is 16. And the product is 1328 kilograms. East. We are confirming the answer with the calculation. Okay. So we have two momenta. So the sort of momentum 1 that we got of the cyclist. Okay, momentum 1 of the cyclist of 83 kilograms is 664. Okay, that momentum is 664 kilograms meters per second. Okay, and then there's momentum 2 kilograms meters per second. Okay. The question is, how are these different? This one is bigger, but by what factor is it bigger? It is 2 times. It's 2 times. So if one increases, then you can divide them like this. Momentum 2 divided by momentum 1. So you're sort of getting the ratio, which is 1328 divided by 664, and then you're getting 2 over 1. Okay, because this one goes twice. Right. So by what factor? Right. By what factor with the momentum? So the momentum increases by a factor of 2. So the momentum increases by a factor of 2. Okay, so because it doubles by a factor of 2 or doubles. So you don't want to say by a factor of 2, so it increases by a factor of 2 or doubles. Okay, that's all right. Just note that. All right. Now I want us to look at other problems here that that we need to solve. Okay, let's look at another example 2. Right. So example 2. Right, in example 2 was saying, let's look at another example now. Let's look at another example. Okay. In example 2, we're saying calculate. Calculate. Okay. All right. Okay, we'll continue. Okay, now we are saying here calculate the momentum. The momentum of an elephant. Of an elephant with a mass of, here's an elephant, a very big mammal, very large. Its mass is 2,000 kilograms. That charges a game hunter. A game hunter at a velocity of 7.5 meters per second north. We look at the solution now. Right, what is the solution to this? Right, we need to calculate the momentum of an elephant. What is the solution to this? The momentum of an elephant with a mass of 2,000 kilograms that charges a game hunter at a velocity of this. We want the momentum of the elephant. What is the momentum of the elephant? Obviously, the question is making mention of two objects here. The question is mentioning an elephant, but also a game hunter. So there's somebody there who is hunting for elephants. Right. There's somebody who is hunting for elephants there, and now he's hunting not only the elephants, obviously, but he's hunting for game, animals, wild animals in the bush. And now, when he's hunting in the bush, suddenly, boom, this elephant goes head to head with him and starts actually charges a game hunter and starts pursuing this guy. And now let's find the momentum of the elephant. Okay, first they're saying calculate the momentum. So from the question, you write down the data, calculate the momentum. So the momentum is what we want. Okay. Um, right. And then what is the mass? Right. So which means therefore the mass is actually 2,000 kilograms of the elephant. And then we continue. What is the velocity? The velocity v is 7,5 meters per second. North. Okay, 7,5 meters per second north. Because velocity is a vector, so each time we give velocity, we must state the direction. But mass is just a scalar. So if we say how heavy is the elephant, we say its mass is 2,000 kilograms. In which direction is the mass? Mass has no direction, so it's just mass in kilograms or grams, whatever. Right, so we want the momentum. So here's the formula. So the momentum is P equals mv. What is the mass? Is 2,000. 7,5. And if you multiply these two guys, you'll get the answer. What is the answer? Right, so the answer at this point is the results after these two have been multiplied. For example, so we have 2,000 times 7,5. And this is exactly 15,000. 15,000 kilograms meters per second. North. Okay, you note these being the thing, being the momentum of the object, being the momentum of the elephant, excuse. And it is north. So it is in the northerly direction. Right, so we've found this and we've answered the question. Calculate the momentum of an elephant with a mass of 2,000 kilograms that charges a game hunter at a velocity of this. Okay, you need to look at a couple of things. What is the game hunter doing here? Is the game hunter supposed to be part of the calculation? Well, obviously not, because you understand the game hunter is just somebody who is presumably running away from the elephant, because this elephant is charging against him, and this is a large mammal that's so huge. Okay, gigantic. Now let's do more calculations. Let's do more calculations right now. Now, what about if we want to calculate the momentum of a bullet with a mass of this fired at a velocity of the south, example 3? Right, let's look at example 3. What about if we want to find the velocity of the bullet of a gun? Example 3. Calculate the momentum of a bullet with a mass. Right, with a mass of 40 grams fired at a velocity of 600 meters per second south. Okay, let's look at this situation right now, and we understand this, and we are looking at the solution. We're looking at the solution to this. Right, so what is the solution to this? Okay, we need to calculate the momentum of a bullet with a mass of 40 grams fired at a velocity of 600. Let's calculate this one. So we need to write down the data. Every time in physics, if they give us information, velocities and mass and things, we write down the data. Okay, now there are a couple of things we need to consider, folks. What do we need to consider? We need to consider the fact that we have the momentum of the bullet that is to be found. So calculate the momentum, excuse. Momentum. All right. So the mass. The mass is 40 grams. Right. So if the mass is 40 grams, there's a problem with the mass. What is the problem with this mass? Because this mass is in grams. The gram is not the SI unit of mass. So we must deal with it.
We need to convert it into kilograms.
Yes, we must convert it to kilograms each time if we're in physics. Okay, in physics we use kilograms. In chemistry we can use grams, yeah, but in physics we use kilograms. That is the SI unit. Okay, right. So this is different from chemistry. Paper 2. So this is paper 1. So you need to know that now to convert this, you need to know that 1 kilogram is 1,000 grams. And this, you divide everything. So which means 40 divided by 1,000, which is 0.04. Okay, normally it's common. It's common to use. It's common to use the thing. Okay, yeah. Okay, just 1 minute, guys. I'm just answering a call now. Okay. Yeah. All right. Hello, ma'am. Yeah, ma'am. Yeah. Yeah. I'm classing, you know. Yeah. Uh-huh. Okay. Oh, okay. Ngiyabona, man. Mm-hmm. Mm-hmm. Yeah. Yeah, bona babe right. Babe right impela, man. Yeah, babe right impela, and that is the correct. That's the correct way of doing things. That is my belief as well. I think it's tinkolo letitsite. So obviously, I mean, we somehow share tinkolelo sasikholwa ngendlela efanayo. Mhm. Yeah, kodwa ngibongela ukuthi kube naleyo discussion and nami ngivumelana nabo kuloko. Ya, siyavumelana impela ke, so ya sitawuthinisana kanjalo, kodwa ngibonge lokuthi babe nendlela le nami lengivumelana nayo kwentatini. Ya, so hayi, ya siyabonga impela maki. Okay. Ya. Ya. Mhm. Ya. Ya, obviously I mean tawukhatha ama expenses. Kodwa amongst other things, obviously, I mean, lo msebenzi wentekile, you know, yeah, that's correct. Kube naloko nje kufezeka kwesidingo njengoba bekuplanwa. Yeah, kodwa ngibonge their intervention, man. Okay. Yeah, and obviously my expenses abe cut out of the picture. And ngaleyo ndlela siyabonga kakhulu, sitawuthinisana then ngekuhamba kwesikhathi manje. Yeah. Mhm. Okay, siyabonga manje, sitawuthinisana then. Okay. Mhm. Yeah. Yeah, siyabonga kakhulu manje. Yeah, nani sinifisela lokho uthola etinhle impela. Mhm. Yeah, siyabonga kakhulu, sitawuthinisana kanjalo manje. Mhm. Okay, siyabonga kakhulu manje. Okay. Okay, thanks. Goodbye, Mike. Goodbye. Thanks. All right. All right, guys. I was just speaking to mommy here because the mothers sometimes are aggressive. The truth is, I don't like just taking calls, but hey, my mom is something else, you know. If I ignore her calls, then she's gonna be angry at me that I ignored her calls. If ever I'm to say I did not take your calls, okay, yeah. If I say to my mom, I didn't take your calls because I was busy, I lost someone here. Who did I lose?
You lost Ayanda.
I lost Ayanda. Okay, that's fine. She's going to get the video. All right, my apologies. All right. Right, so the mass is this, and now we have the velocity. What is the velocity? Right, the velocity obviously is 600. It's exactly 600. Okay, even if in case the sound quality rattles, do not worry because the video quality is just gonna be perfect. So do not worry that the sound quality is this and that, you know, and so on and so forth. Right, so obviously then the momentum is P equals mv, and we put the mass, which is 0.04 kilograms, and we multiply that by the velocity, which is 600 meters per second. And now then, in the end, then we have
24.
okay, yeah, we have the calculation. What do you get if you calculate?
It's 24.
24. Well done. Okay, that is the correct answer. Well done. So it is 24 kilograms meters per second. So I'm excited that you are on point. So obviously the velocity is south, and therefore the momentum will also be south. So the momentum is always in the same direction as the velocity. So we understand therefore that the velocity of the bullet is exactly 24. Well, the momentum is 24 kilograms meters per second south. Right. So that's something that you need to note. Okay, now what about if we're dealing with a soccer player? Oh, let's deal with a dog. Let's deal with a dog. Now, sometimes we might be interested in finding the momentum of a dog. Example 4. Is it example 4? I believe it is 4 because the other one was 3. Yeah. Example 4. Calculate. Calculate the momentum. The momentum of a 30 kilogram dog at, or rather that runs. Okay, so yeah, that runs at a velocity of 8 meters per second west. Right, we look at the solution to this. Look at the solution to this. Calculate the momentum of a 30 kilogram dog that runs at a velocity of 8 meters per second. So how do you find the momentum of the dog? So we note the data first. Right, so the data, it's going to be what? It's going to be momentum P. It's a question mark. The mass is 30 kilograms. The velocity is 8 meters per second west. So we're interested in finding the momentum, so which means that the momentum is mv. The mass is 30 kilograms. The velocity is 8 meters per second. Okay, 30 by 8 is
240.
Well done. 240 kilograms meters per second. Right. Obviously, with this, then said we're able to see that it is in the western direction. Okay, because we want to calculate the momentum. So we found the momentum. Right, and then example 5. Example 5. Right. So if we say calculate the momentum, of a 30 kilogram dog that runs at a velocity of 8 meters per second west. How fast must, okay, this question is like similar to the previous one, but there's an extension. How fast must a 70 kilogram person run to have the same momentum Okay, I'm having eye on the back. Right. How fast must this 70 kilogram person run to have the same momentum as that of the dog? Okay, so how fast must a 70 kilogram person run to have the same momentum as that of the dog? All right, so now we have this question. And let's look at the solution to this. What is the solution to this question? We need to calculate the momentum of a 30 kilogram dog that runs at a velocity of 8 meters per second west. How fast must a 70 kilogram person run to have the same momentum as that of the dog? Right, so let's look at this question in example 5 and solve the problem together. Right, so there are a couple of things that are very important. So we need to look at the data. Right, so in view of the data, right, so first we need to calculate the momentum. So the momentum of a 30 kilogram dog is what we want. The mass is 30 kilograms. And the velocity is 8 meters per second. West. Right, so what is the momentum of this dog? So we know that momentum is mass times velocity. The mass is 30 kilograms. The velocity is 8 meters per second. And we saw before that this is 240 kilograms meters per second, and this is the momentum west. Okay, how fast must a 70 kilogram person run to have the same momentum? So obviously at this point, we are having the mass of a person So in other words, we have the mass, which is 70 kilograms. And this is the mass of a person. So if this is the mass of the person, what do we know about this person here? This person will have the same momentum as the dog. So which means momentum is mass times velocity. Okay, this person is going to have the same momentum as the dog. So which means 240. Because the dog has 240 kilograms meters per second of momentum. Right, so this implies that. So in other words, if the momentum equals is P equals mv, and now we're then saying how fast must this 70 kilogram person run? So we have 70 kilogram. How fast? The mass of the person is 70 kilograms. We put 70 here, and then we multiply by the velocity. And then now we want to find the velocity. So we need to divide by 70 on the left and divide by 70 on the right. And what then do we get here? What then do we get here? So what we're able to get here is that the mass is 240 over 70, or rather the velocity is 240 out of 70. And then if you use a calculator to say 240 divided by 70.
24 over 7.
Yes, what do you get?
24 over 7.
You get 24, yes, 24 out of 7, which is the same as what? 3,
Same as 3,42.
42.
7 divides 21 with remainder what? 3.
3.
Okay,
3,
yeah, which is 3,
42.
yeah, 3,42 or 3,43 to the nearest.
43. Yeah.
Right,
43.
3,43 kilograms meters per second. Okay, and obviously remember how fast my 7 kilogram run to have the same momentum as that of the dog. Remember, the momentum must be the same. So same momentum tells us what? The velocity must have direction. What is direction? It is west.
West.
Direction is west. Direction is west. Okay. Now let's continue and we do more questions. Okay, we dealt with this dog. What about if we have this situation here? Right. Okay, let's look at the something we call a go-kart. Example 6. A kart. Example 6. Example 6. So a 45 kilogram. A 45 kilogram go-kart. And the driver. And the driver of 55 kilograms. Both have a velocity of 12,66 kilometers per hour west. So a 45 kilogram go-kart and the driver of 55 kilograms both have a velocity of 12,66 kilometers per hour west. Calculate the momentum of the go-kart. Calculate the momentum of the go-kart. Two, calculate the momentum of the driver. Calculate the momentum of the driver. 3. Calculate the momentum of the driver. Okay, we said of the driver before, but this one is of the driver and go-kart system. Four. Okay. Draw velocity and momentum vectors for the 4.1 go-kart. .2 driver. 3. 4.3 driver and go-kart system. Driver and go-kart system. Okay, let's look at this one now. Solution. What is the solution to this? Okay. A 45 kilogram go-kart and the driver of 55 kilograms both have a velocity of 12.66 kilometers per hour west. We need to calculate the momentum of the go-kart. Okay, let's look at the mass of the go-kart. What is the mass of the go-kart? It's 45 kilograms. And that of the driver is 55 kilograms. And so both have a velocity of this. Okay, now what is the solution to this? So in number 1, the data, which means we have the momentum. We're looking for the momentum of the go-kart, but the mass of the go-kart is 45 kilograms. The mass of the go-kart is 45 kilograms. And the driver, okay, but now we're looking at the go-kart. The mass is this, and the velocity is 12.66 kilometers per hour. Tell me, what is the momentum of the go-kart? So, which means the momentum is mass times the velocity. But this velocity is not good. Right, the velocity is not good because it is in kilometers per hour. We want the velocity to be in meters per second. So let's convert it. Which means we have 12.66. Now the kilometers per hour would be the same as what? Okay, so now you need the kilometer. What is the kilometer? The kilometer means you multiply by 1,000. Kilo means you multiply by 1,000. And then you divide by an hour. 1 hour has 60 minutes. Multiplied by each minute has 60 seconds. And therefore, each minute has 60 seconds, like so. And therefore, this velocity right now is the same as that. So yeah, you need to just do a calculation here. You need to okay, yeah. Okay. All right. Yeah. Anyone? I'm doing calculator, please.
Yeah, it's 211 over 60, and then when you convert it, it's 3.56.
Okay. All right. You getting that answer? Is Ayanda getting the same thing? Or maybe Ayanda is not done it yet. Or maybe I lost Ayanda. It's possible. I will check. I will check.
Yes,
Okay.
sir.
12.66 times 1,000. Okay, I'm just checking also Lerato to make sure that we write correct answers here. Times that. Yeah, so you got 3 comma.
3.52.
Yeah, 3.52 meters per second. Velocity is direction, so it is west, in the western direction. But now just, oops, right, just note that. Right, so it is 3.52. And that means actually the mass is 45 kilograms. The SI unit of velocity is it's meters per second. So it is 3.52 meters per second. So if you multiply these things, what do we get? Okay, so yeah, we might just multiply these. So with 45 times 3.52, 158.
158.4.
8.4 kilograms, meters per second, west. So this is the momentum of the go-kart system. Is the momentum of the go-kart, or of the go-kart. It is the momentum of the go-kart because this is the mass of the go-kart. This is the mass of the go-kart. Okay, right. The next question is this one. We need to calculate the momentum of the driver. What is the momentum of the driver? So we have the mass of the driver. The driver has a mass of 55 kilograms and a velocity of this much. So let's look at number 2. Number 2. Right, so number 2, we have data, velocity, momentum. Momentum is what we want, but what is the mass of the driver? Okay, we saw that the mass of the driver is 55 kilograms. And the velocity of the driver is 12 3.66 kilometers per hour. Okay, kilometers per hour is the velocity normally of cars and trains and airplanes, but normally we need the SI units, and we have already just got that. And we got that it is 3.52 meters per second west, 3.52. So you convert this one, find 3.52 meters per second west. Now, with that said, we want to find the momentum of the driver. So momentum is mass times velocity. The mass is 55 kilograms multiplied by the velocity, which is 3.52 meters per second. What is then the momentum? Okay, we need to use a calculator here. So anyone calculator? So we need to multiply these two. So in other words, we say 55 times 3.
It's
193.6.
193.6.
Yes, sir.
All right, good. 193.6 kilograms meters per second west. Okay, so this is the actual momentum of the momentum of the driver. Is the momentum of the driver. So we continue. We continue. Okay, we continue. So is the momentum of the driver. Okay, the couple of things then that obviously we need to still do. What about the third question? Calculate the momentum of the driver and go-kart system. So in other words, the driver and the go-kart are now together. If we combine them together and want to find the momentum of everything, because this driver is actually now driving the go-kart. Okay, right. So number 3. Number 3. Okay, so in number 3, we're gonna look at the thing. The driver in the go-kart system. So we are focusing on data, but we're interested in the momentum P. And then the velocity we know is 12.66 kilometers per hour, 3.52 meters per second west. The mass. The mass is 45 kilograms plus 55 kilograms. And therefore, if you add these, what do you get? 100 kilograms. Okay, this is the mass. So which means, therefore, if we are combining the driver and the go-kart, because the go-kart has a mass of 45 kilograms, but the driver is a bit heavy. It's heavier than the go-kart, so by just 10 more. So it's 55 kilograms there, meaning the momentum. Right, meaning the momentum is mv. The mass is 100 kilograms multiplied by the velocity 3.52 meters per second, and the product. So now we must just multiply these two things. So it's 100 times 3.52, which is exactly 352. You're getting that, right? 352 kilograms meters per second west. Right, so this is the momentum of the driver and the go-kart system combined. So the driver is driving the go-kart system, like finding the momentum of the driver and the car together. Okay. Now we want to find something else. Number 4. Number 4. Draw velocity and momentum vectors for the go-kart and the driver. Draw velocity and momentum vectors for the go-kart and the driver. Okay, let's draw the velocity and momentum vectors for the go-kart and the driver. All right, so first in 4.1, we must draw the velocity and momentum vectors for the go-kart and then the driver. We did this before, but yeah, we are for a different question, but we're back. So we're looking at number 4. Right, we're looking at number 4, but with a specific focus on 4.1. Right, so number 4.1. Okay. We want to draw the velocity and momentum vectors for the go-kart. Velocity and momentum vectors for the go-kart. Okay. What is the velocity of the go-kart? Okay, we know that the velocity of the go-kart is 12.66 kilometers per hour. 3.52 meters per second west. Right, so, but we know the momentum. What is the momentum of the go-kart? We got it before, so let's just check. Right, the momentum of the go-kart is 158.4. 158.4. 158.4 kilograms meters per second west. Okay, so if we were to say now the velocity and momentum vectors, which one is bigger here? 3.52 is certainly smaller than the other one. So it means that now you're going to have, if you decide that this one is the velocity, which is 3.52 meters per second west. And then now can extend this a little bit. Make it longer, like so. And then now you can have this one, which is the momentum. 158.4 kilograms meters per second. So we can see it's bigger because it's 158. 158 is a bigger magnitude. Magnitude means the size of the vector. So yeah, it's longer. So we have drawn the velocity and momentum vectors for the go-kart. And then now we need to look at 4.2 of the driver. Of the driver. Of the driver. We're looking for the velocity and momentum vectors. Okay, now at this point, you need to remember the velocity. Okay, it is exactly what we got before. 12.66 kilometers per hour, 3.52 meters per second west. Now note this. So the momentum of the driver, we got it before, right? The momentum of the driver Momentum of the driver is 193.6. 193.6. 193.6 kilograms, meters per second, west. Okay. So, we are good. We are so good. Okay, now we need to draw. Okay, now this is 3,52 and the other one is 193. So yeah, we draw. So we're going to draw the velocity is 3,52 meters per second west. Okay, if you wish, you can even draw it like so. Because of the cardinal directions. And then now if you draw this one here to be 193 momentum, 193.6 kilograms, meters per second west. So that is going to be exactly the momentum and the velocity of the driver in the western direction. Okay. What about the driver and the go-kart system combination? 4.3. Right. The driver and go-kart system. Okay, what is the velocity? Right, we saw that it is 12.66 kilometers per hour. Exactly 3.52 meters per second west. Momentum of the system. Right, so, okay, we added the mass of the go-kart and the driver, and we got 100, and we got the momentum to be 352. We got the momentum to be 352 kilograms, meters per second, west. So now it's easy, then you can draw. The velocity is 3.52 meters per second, west. But the momentum is bigger. It's 352 kilograms, meters per second, west. Like so. Now, we have this. We have this. Let's look at some exercises. Let's look at a home activity for you. A home activity. Right. As we look at this home activity, we look at part 1. Let's call it number 1. Right. A soccer player. A soccer player experiences a momentum a momentum of 760 kilograms, meters per second, while running at 8 meters per second west. Calculate the mass of the player the home activity for you. Okay, I'm giving another question now. Another question. Two. A bicycle right a bicycle has a momentum of 24 kilograms, meters per second, in a northern direction. Northern direction. Okay. Calculate the new momentum of the bicycle if in 2.1 the velocity doubles. 2.2 the velocity quadruples. Two point three. The mass doubles. 2.4. Both the mass and velocity doubles. 2.5. The velocity increases. Increases 3 times. Okay. Or the mass increases 3 times and the velocity is halved. Is halved. Okay. Home activity for you, number 3. A 40-ton truck moves at 2.5 meters per second north. What velocity should a 1,500 car 1,500 kilogram car be traveling at in order to experience the same momentum as that of the truck Okay, so we have this of the truck. Right, a 40-ton truck moves at 2.5 meters per second north. What velocity should a 1,500 kilogram car be traveling at in order to experience the same momentum as of the truck? So just note that. So this is just a home activity for you. This is the home activity for you. Right, so in other words, we have this question. Okay, so these questions, you need to try them and make sure that obviously you're able to do these questions, because they are very important for us to be able to make the kind of progress we want if we are to actually become the science people that we need to become. And so we're going to just obviously continue. I think that what I'm going to do right now is I'm going to give you time to try these questions, and then we shall return again. So yeah, this is, I think, enough for today's physics. Try this home activity, these few questions. There are more questions I could give, but yeah, these are a bit enough for a start. You need to send me pictures of the answers so that I can mark. And then in my next appearance, I'm going to discuss the answers to these questions before we move to the next section. Okay, because this is like one section, and then when we meet again, we shall do the next section. Okay. So this video is going to be available. So I'm going to post this video in the next couple of minutes for you to access the video. Watch this. Okay, these you need to write them in your book, because when you're discussing, you're just watching, because we're just moving. But you need to have a book for us, for our discussions, for physics. or for physical sciences, because we're gonna be doing both physics and chemistry. So you need to have a separate book where you're gonna be writing these things, all of them. You need to write them, the examples and the solutions, because I'm gonna ask you these things at some point. But sometimes during our discussions, I give information. But there are times when we're gonna have like discussions where you're gonna have your own inputs. You're gonna try the questions and we're gonna verify if you're right or wrong during the discussions. Right, for today, this is the first section. I must thank you for joining us. We're gonna chat on WhatsApp, but every day, let's make it 9:30 in the morning. 9:30 in the morning, we meet and we discuss. The next discussion must be at 9:30 tomorrow morning. We're gonna be doing more life sciences tomorrow. So be ready for life sciences tomorrow. Ayanda, do you do life sciences?
Yes, sir.
All right. We're going to be doing life sciences tomorrow to make sure that you're able to get the life sciences understood as well. The physics and the math, you need to get them understood. So we're going to be meeting tomorrow at 9:30, more life sciences. I must thank you guys for joining us today. Please try these and send me pictures of your answers so that I'm going to mark and we shall continue tomorrow. But I can decide to come back later today, you know. I can decide. So I'll let you know. If I decide that we have another lesson later on today, I'm gonna let you know. But 9:30 is always guaranteed in the morning. Okay. Until schools reopen. Okay.
Can you please put me on the evening ones as well, Sunshine?
Okay, that's fine. I'm gonna put you on the evening ones. So yeah, I'm just gonna notify you of the evening time. Okay.
Please.
All right.
Even
all
if you're
right.
doing
Okay.
life science or anything.
Yes. Okay. Okay, I must thank you
Okay,
guys, but
thank
I'm gonna
you.
chat on WhatsApp. I'm gonna send you more information on WhatsApp about the evening discussions. Okay. Right. So
Okay,
thanks a lot,
thanks,
guys.
Sunshine. Bye.
Okay, thanks, guys. Goodbye, guys. I'll send the video in the next couple of minutes. Okay. Yeah, thanks, guys. Goodbye.
Bye.
Bye, guys.